Good morning, everyone. I'm happy to see you here on a Wednesday morning, and welcome to the session. I hope you've been enjoying reInvent so far. This is my first reInvent, and it's been pretty amazing. I've had a lot of conversations with many of you, and it's been fun. I've learned quite a bit this week from your inputs. My name is Ramesh Kumar, and I'm a Principal Product Manager in the AWS Snow service team, which includes a family of secure and rugged devices that help you with your edge computing and data migration workloads. So what we're going to do here today is to walk you through how the AWS Snow family of devices can meet your requirements for edge computing and data migration. We have a very special guest here today, Matt Johansson from Novetta, who's going to come up here on stage and walk you through how his organization has made use of the Snowball Edge devices for edge computing applications. And then we'll leave some time for you to ask any questions that you may have at the end. Okay, so let's move on. For the first 20 minutes or so, I'll provide you with an overview of the AWS continuum of deployment options from the cloud to the edge, provide you with an overview of the AWS Snow family of devices that can meet your requirements for edge computing and data migration. I'm also going to go a little bit deeper and dig deeper into showing you how you can use the Snowball Edge devices for your edge computing workloads and applications. And then Matt will come up here on stage and walk you through how his organization, Novetta, has made use of the Snowball Edge devices for edge computing in a disaster response application. I think you'll find his talk very interesting. And then I'll come back on stage and spend about 10 minutes or so walking you through how you can use the Snow family of devices for large-scale, multi-petabyte data migration. And along the way, I'll provide you with some real customer use case examples for both edge computing and data migration. Towards the end, we'll leave some time for any questions that you may have. All right, we have a lot to cover, so I'll jump right in. Companies are moving more and more applications to the cloud, but not all applications are moving to the cloud. Customers require to collect data, process data, and store data at the very edge of the cloud, and sometimes even beyond the cloud. Customers are looking for infrastructure and software deployed at the edge where they can collect data, analyze it, process it, store it, and move it to the cloud. AWS provides customers with managed hardware and software for just doing that, for deploying devices, hardware, managed hardware at the edge, collecting, gathering data, analyzing it, processing it, storing it locally, and when they're ready to ship the data to the cloud, they can do so. When you look at the edge, it means a lot of different environments based on the customer's use case. The edge could mean a data center, but it's more of a minimally configured data center where you're running applications that need the real-time processing and real-time capabilities. The edge could mean a remote office. The edge could mean an IoT edge on a factory floor or IoT in devices. The edge could be the rugged edge in remote and austere locations where you may have intermittent network connectivity or no network connectivity at all. Or the edge could be a mobile application. With 69 AWS availability zones spread across 22 geographical regions worldwide, the AWS cloud provides customers with full scale, elasticity, service offering, online management, monitoring, and telemetry. But as you know, game developers have players all around the world. Media companies are developing content and editing content at multiple locations. Financial firms are running high-frequency trading across multiple financial exchanges. And others are developing applications that need to interact with their end users. the requirement for low latency computing at the edge continues to grow strongly all over the world. We started the Snow service a few years ago with the Snowball device, which is a secure, rugged, suitcase-shaped device which has storage capacities of 42 terabytes or 72 terabytes. It weighs less than 50 pounds, which is OSHA's limit for a single person carry. Customers have used the Snowball device to move data to AWS, including analytics information to their data lakes, healthcare imagery and healthcare records, video content, and other media content. The Snowball device, just like all the other devices in the Snow family, is secure and tamper-resistant. The hardware and software is cryptographically signed. All the customer's data is automatically encrypted with 256-bit encryption keys that are owned and managed by the customer. Although the Snowball devices have helped customers move up to a petabyte of data to AWS, some customers started asking us for the ability to move even more larger amounts of data to AWS. Some customers wanted to move tens of petabytes of data to AWS. Some other customers wanted to shut down their data center entirely and move all their content and data to AWS. To meet these customers' requirements, we introduced the AWS Snowmobile device, which is a secure and rugged 45-foot-long shipping container that can help customers move up to 100 petabytes of data to AWS. I mean, look at 100 petabytes of data and put that in perspective. It's, of course, over 1,000 Snowball devices, and it's about equivalent to 5 times the total data in the US Library of Congress, including all their digital content. An example of a customer who used the Snowmobile devices is Digital Globe, who's now a group within Maxar. And Digital Globe is one of the world's leading provider of high-resolution satellite imagery and data analysis behind it. They moved 17 years of data, content, and images from their data center to the AWS cloud using the Snowmobile devices over a period of just 4 weeks. Although customers have been thrilled to use the Snowball and the Snowmobile devices, they started asking us for something else. Customers wanted to take their applications from the cloud and run it at the very edge of their businesses. They want to take their applications and workloads that they've developed and tested on the cloud and run it in places like mines, oil fields, factory floors, industrial sites, ships, and defense installations, where the secure and rugged casing of the Snowball device is required. This drove us to develop the Snowball Edge device, which is a little more storage capacity, total of 80 terabytes of storage capacity, but more importantly, it also supports computing. For the past 2 years or so, we've been working on increasing the improving the compute capability of the Snowball Edge device. And today, you can run EC2 computing on the Snowball Edge device. You can take applications and workloads from the cloud, such as data analytics, machine learning, and even video analytics in a video surveillance or security type application, and image analysis on the Snowball Edge device. Over the next few slides, we'll dig a little deeper into understanding how you can use the Snowball Edge devices for computing at the edge, and show you 2 customer edge computing examples and use cases with the Snowball Edge device. So where do customers run computing at the edge? Customers use the Snowball Edge device for edge computing in environments where there's intermittent network connectivity, such as factory floors, industrial sites, or in transportation. They also use the Snowball Edge for edge computing in environments where there's no network connectivity, such as ships or in defense installations. The US NGA and Netflix have operations at multiple locations around the world. NGA and Netflix collect data, process data, store data, and move data amongst their different locations, and this data includes satellite imagery and media content. And they do so with the Snowball Edge devices. Philips Healthcare is an example of a customer that collects data from medical devices that are deployed in healthcare facilities. They process the data and ship the data to AWS. Transportation customers are increasingly asking for the ability to collect data from the environment surrounding their vehicles. They're also looking to collect the data from the various sensors in autonomous cars and other truck fleets. They want to process that data and ship the data to AWS. AWS offers two options for edge computing: AWS Outposts and AWS Snowball Edge. Although this session is focused on the Snow family of devices, it's good to take a minute to understand the environment that is suitable for using AWS Outposts and the environment that is suitable for using the AWS Snowball Edge for your edge computing use cases. AWS Outposts has been designed for an environment that is a traditional data center with consistent network connectivity. These could be a data center on an on-prem location, it could be co-location sites, or it could be telco central offices. Essentially, you would use the AWS Outposts in places or an environment where you have consistent network connectivity. Control plane functions, such as provisioning, take place at the edge. Replacements and upgrade takes place at the edge. For Snowball Edge, you would use it in an environment that is non-traditional, remote, and austere locations, places where you either have intermittent network connectivity or no network connectivity at all. You don't need a full data center setup. Control plane functions such as provisioning cannot be done at the edge. If you want to replace or upgrade the device, you ship the device back to us, and we'll ship you the replacement and upgraded device. To expand your storage capacity and your compute capacity, you simply add more Snowball Edge devices. There's two options within Snowball Edge. One is called Snowball Edge Storage Optimized, and the other is called Snowball Edge Compute Optimized. Both devices offer you storage capacity on the device as well as EC2 computing capacity on the device. The Snowball Edge Compute Optimized device has 42 terabytes of storage capacity. It has 52 virtual CPUs of compute capacity. You also have a choice of adding an NVIDIA GPU for accelerated workloads. The Snowball Edge Storage Optimized device, on the other hand, has a higher data capacity, storage capacity of 80 terabytes, and it has 24 virtual CPUs for compute capability. Both Snowball Edge device configurations can be run in a single node mode, if you will, or you can cluster a number of devices, cluster multiple of these devices to have either a larger storage capability or run more complex applications at the edge. Both Snowball Edge devices are available as hardware, as a managed hardware, and as hardware as a service for long-term deployments at the customer sites with discounted 1-year and 3-year lease options. So let's dig a little deeper into understanding what is the workflow behind using a Snowball Edge device for an edge computing application. If you look at a factory floor IoT or a healthcare IoT, in these scenarios you have specialized industrial equipment and medical equipment that are generating machine data. This machine data needs to be collected, processed, analyzed at the edge. You may take some decisions based on that analysis at the edge, and then you want to store the data at the edge. When you're ready to ship the data to AWS, you can do so. The space and environment on a factory floor or a healthcare facility is really not conducive to having a stack of servers, networking equipment, and storage equipment. This environment is ideal for the use of a Snowball Edge device. You can effectively create an air-gapped small IT hub with one or more Snowball Edge devices, and you can do this virtually anywhere. For EC2 computing, you can include your Amazon machine image that you've developed on the cloud. Essentially, you develop your Amazon machine image or AMI in the cloud, test it, validate it, and when you're ready, during a Snowball Edge job order, we will provision the AMI for you on the Snowball Edge device and ship it to you. You can also run AWS IoT greengrass processing to gather data, process the data, and store the results. For storage capability on the Snowball Edge device, we support S3 compatible, Amazon S3 compatible storage with an NFS file share, and we support Amazon EBS compatible block storage. So when you look at using the Snowball Edge device at the edge for your computing applications, you get the benefits of a reliable, secure, rugged computing platform that can work in an air-gapped environment or an intermittent network connectivity environment. You're able to develop your application in the cloud, test it, validate it before you run it at the edge. You can collect data, store data, process data, analyze data at the very edge. And of course, we provide the hardware as a managed service with 1-year and 3-year discounted long-term options, which essentially means during that period of 1 and 3 years, if the device needs to be replaced or upgraded, then AWS will take care of that. The way you manage the Snow devices, whether it's Snowball or Snowball Edge, and monitor the devices at your site is through the command line interface. As you can imagine, managing multiple Snowball Edge devices for your compute applications and storage applications at the edge can become cumbersome. Therefore, we are introducing a Snowball Edge Device Manager GUI interface, which lets you manage and monitor multiple Snowball Edge devices. You can use this GUI interface, and it's fairly easy to use for both a technical and a non-technical user to do fast and easy unlock, change and monitor the IP address of the device, change and monitor the names of the devices. You can use this interface to look at the availability of resources that you have on your Snowball Edge devices, whether that's memory or storage availability. You can use it to manage your EC2 instances and your computing instances. You can create, stop, reboot, and run your EC2 instances. Manage your virtual network interfaces. This Snowball Edge Device Manager GUI is not available today, so I'm essentially pre-announcing it. It will be available at the end of Q1 2020. Now I'll provide 2 customer edge computing examples using the Snowball Edge device. The US NGA is a key partner and sponsor of the AWS secret regions. They develop secret-level US security classification workloads that is available to all the US intelligence community. They support multiple locations all around the world. They move data everywhere, and the data could be things like the map of the ocean floor. They have 12 million images. They've carried out 50 million indexed observations, and 75% of these observations are automated. They would require about 8 million analysts to do the work. We, of course, do not have 8 million analysts. 8 million analysts with that capability don't exist in the world. The NGA uses artificial intelligence to make this happen. Commanders who are responsible for their theaters, when they ingest data, they want to quickly know gain insights into pictures and content and data. There's a new picture, they want to know what's in it very quickly. They use Snowball Edge devices at the edge to make this happen. There's a need for a common repository of the images, content, and data so that folks in all locations around the world have a common knowledge and awareness of all the data and content. The US NGA has developed such a repository, but there are some risks and challenges. Here comes Project Odyssey. And with the Project Odyssey, the NGA wants to deliver the content and images and data from the cloud to the edge. They make use of contract vehicles filled with Snowball Edge devices that have all their data and content and ship it to the edge. They literally physically move the cloud to the edge, and they do this in multiple locations. Typically, they've had a 5 to 7 year infrastructure and hardware upgrade cycle. With Snowball Edge devices, they can now have an upgrade cycle in every 6 to 8 months. The NGA is storing over 1 petabyte of data on the Snowball Edge storage optimized devices. They're running their custom developed image analysis applications on the Snowball Edge compute optimized devices. They're also running commercial applications on the Snowball Edge compute optimized devices. The next example is a disaster response example. And before I jump into it, I'll spend a quick minute introducing the AWS disaster response team to you. The AWS disaster response team is a team of AWS technical professionals who provision, transport, implement, and redeploy AWS Snowball Edge devices in disaster locations and disaster zones. They work with the customers to pre-select software stacks and applications ahead of time, which get provisioned in the Snowball Edge devices, and then they're shipped to the disaster zones. Of course, they work with the customers ahead of time to simulate their applications, so we know that things will work smoothly in a disaster zone. Hurricane Dorian, which was a Category 5 hurricane, hit the Bahamas in early September 2019 and caused extensive damage across the islands that make up the Bahamas. Hurricane Dorian is one of the 2 most intense hurricanes to make landfall in the Atlantic Ocean, and it caused extensive damage. Help.ngo was engaged to fly drones across all the islands and capture aerial imagery to help assess the damage. The AWS disaster response team worked with Help.ngo, and they made use of 2 Snowball Edge compute optimized devices to analyze the imagery captured by the drones, to assess the damage, and provide that information to the humanitarian response teams. A member of the AWS disaster response team spent over a week in the Bahamas working with Help.ngo to analyze the aerial imagery captured by the drones and help them use the Snowball Edge devices. So they were able to speed up the analysis of the images, get a quicker understanding of the assessment of the impacts, and then help provide that information to the humanitarian response teams. A quick look into the technical aspects of the work done by Help.ngo and the AWS disaster response teams. So 2 Snowball Edge compute optimized devices were selected for their compute capability. They were provisioned with the image analysis software before the devices were shipped to the Bahamas. A computer with a tool that helped take the data, aerial images captured by the drones and from their SD card, and transport it or copy it to the S3 storage on the Snowball Edge device. And then the image application software running on the Snowball Edge device could carry out the analysis of the aerial images. The AWS disaster response team person who was on site worked with the help.ngo team, and they quickly realized that the Snowball Edge compute-optimized device had significantly higher levels of compute capability. So on the ground, they were able to adapt the image analysis application and to take advantage of parallelizing the image analysis tasks, make use of 9 EC2 instances on the Snowball Edge device, and they were able to quicken or shorten the time that it took to analyze all the images, and they were able to give that data to the humanitarian response teams much faster. All right, I'm super excited to bring Matt Johansson up on stage. Thanks, Matt.
Hey, everybody. My name is Matt Johansson, and I'm the director of cloud services at Novetta. Hold on, wait. You're not through the... Good now? All right, good. Let's try that again. My name is Matt Johansson. I'm the director of cloud services at Novetta. Novetta is an advanced analytics company that focuses primarily on defense and national security workloads. I'm really happy to tell you a story today about how we were able to go out into the field with Amazon's disaster response team that Ramesh just mentioned. But before we do that, just a couple topics that we're going to cover today. A little bit of background about me. I want to tell you about something called Operation Convergent Response, which is actually an event hosted by Verizon every year. We're going to go into a little bit of solution architecture about how we use the Snowball Edge device, specifically the compute-optimized version. And then we'll talk a little bit about our solution that involves something, IoT, our platform called Aegeon, and machine learning, all running at the edge, whether it be in a completely disconnected environment or when you do get connectivity. So, just a little bit of background. I wear two hats in our organization. My first job is to manage our alliance with AWS. So I'm the, what they call the alliance lead, or the person responsible for working with the partner team to make use of all of the different products and services as they come out and get them in front of our customers as fast as possible. I also sit in a group called Special Projects, which gets to work on interesting rapid prototyping efforts like the one that we're going to talk about today, which involves bringing our mission-proven solutions to new use cases. And we're really excited about how our C4ISR platform is helping disaster response. When I'm not doing either of those two things, I have two young kids, and I love being outside. So, first, what is Operation Convergent Response? This is a fantastic opportunity to go out in the field with Verizon and AWS to actually serve during live scenarios at a place called the Guardian Centers in Perry, Georgia. The Guardian Centers is a full-scale facility that can simulate things like floods, counter-terror situations. I literally saw helicopters landing on buildings at this place 2 weeks ago, right? So the idea is Operation Convergent Response gives first responders, disaster management, and law enforcement groups an opportunity to come together to see how solutions work. This is not like your average trade show where somebody's up on stage or at a booth doing a demo. You have to set up your solution in the field so that people can see how it works with actors and responders actually doing their critical mission. So AWS, the disaster response team, invited Novetta to participate because they thought we could help solve a hard problem that many first responders face during these disasters, which is simply keeping track of people and critical equipment. So imagine different volunteer groups showing up in the Bahamas. How do we put them all on the same map so that we can ensure something as simple as health and safety of the very volunteers that are trying to help? Well, To do that, let's talk about the tech a little bit. And I'm going to keep this very high level. I'm actually doing a chalk talk later on this morning if you guys want to come see some of the lower level detail. But it's very simple. Let's deploy inexpensive IoT sensors to start, so basic GPS trackers, right? And HD security cameras, cameras that you can just order on Amazon.com, like an Axis ball cam, we call them. You see them hanging off the sides of buildings or in offices. Nothing too crazy. We're going to get all that data into the compute-optimized Snowball Edge so that people can use it in the field. Digging a little deeper, I want to tell you about a couple of things here. Show of hands. How many people have heard of something called LoRaWAN? Okay, good group, and not all just Novetta people up here in the front. So LoRaWAN is an emerging IoT technology. It's very popular in Europe and Asia for industrial applications. It stands for long range, low power. So think battery devices that can communicate over digital RF over very long distances. The gateway is basically an antenna that's going to collect signal from all the sensors. The Snowball Edge, obviously, we're using it as our central processing hub. Ramesh did a great job showing you a couple of use cases across various industries for that, and that's exactly what we want to do. We want to bring our software on the Snowball. We actually had 4 compute instances running on the Snowball. We want to get it running quickly. We want to use machine learning via Greengrass, and then we also want to be able to connect to a connected environment. So you can imagine large organizations like AWS want to know where their people are, but they're not going to send the whole company to the Bahamas, right? They might want to see that from afar. So when connectivity does come in, how can we leverage the features of the Snowball Edge to get the data back to the cloud and replicate it there? It's worth mentioning that we were able to get a very high power Windows instance running on the Snowball Edge. So for those of you that have Windows workloads, we were able to provision an instance using the documentation available to get Windows Server 2016 running with our application on the compute optimized device. So a little bit about IoT, something called Aegeon, and machine learning. For reference, Aegeon is a C4ISR platform that the military currently uses for things like base protection and force protection abroad. It's designed to bring any sort of sensor you can imagine into the same platform. So whether it's video cameras that can be controlled centrally, whether it's radar systems, LiDAR systems, doesn't matter. It all comes to the same single pane of glass. But let's start with the sensors. So these LoRaWAN sensors, what are they? It's basically a small puck-sized device that takes a GPS signal, sends its coordinates, its sensor ID, and a timestamp and a battery voltage, very important, up to about 10 miles away in mixed urban settings from just 3 AAA batteries. These sensors cost around $50 each and can be distributed in the field with something as simple as a zip tie, a piece of Velcro, or just in your pocket. We developed a custom application to scan that QR code and reattribute it. So it doesn't matter if I assign it to a person, or I assign it to a vehicle, or an aircraft. It doesn't matter. If I have a pile of sensors, I'm going to get signal from them and put them on the same map. To give you a sense of how that works, we have a little video here that we captured from our time out at Operation Convergent Response that I want to share with you now. All right. So that just gives you a sense a little bit of where we were placing the sensors, how easy it is to put it on a vehicle, a person, really doesn't matter. By the end of OCR, Verizon had asked us to put sensors on the transportation vehicles that were taking spectators to each of the scenarios. We were covering a scenario at the airport over a mile away, and we were able to reattribute those sensors within seconds. So imagine a large box of sensors showing up in the Bahamas or another disaster site and very quickly being able to keep track of people like news crews, volunteer organizations, and any piece of equipment so that you can then see where it is. So on to seeing where it is. So this is an idea we had to show how AGION works. So as the data is coming in, you'll see a boat moving around in what the flood scenario, as they call it. So they have the ability to flood a whole town at Guardian Centers. You'll see as the boat is moving, we get a dot on the map for where that boat is. All we have to do to change the icon to boat is use that mobile app I mentioned, say this is a watercraft, and then we get a boat icon. If it's a person, it'll show up on a dot, much like around the edges where you see people walking around. So we could start by just giving the sensors to team leads. We don't have to give them to everybody. We could just say, hey, there's a news crew that wants to go out to the edge near the hurricane. Let's give them a sensor so we can see where they are. AGION provides the ability to bring in new sensors on the fly. There's a member in the audience here who spent 3 days nonstop integrating different types of drone footage, other sensors. It's built to bring in any sort of data right at the edge without needing to customize the code. Okay? Now, to give you a sense of our setup, we were set up in 2 places. This is the disconnected environment. So we roll out in a truck, right? Set up a tent, and in that tent, you see the Snowball Edge with a screen. That screen was being used to conduct safety briefings for everybody that was coming through to watch the flood scenario. Right there at the edge, did not require any network connectivity whatsoever. All 4 instances to power the solution, just running right there at the edge. Now, when the backhaul did come in, we were able to send the data up to an instance of AGION hosted in EC2, US East, and we were able to bring that application up at the conference building about a mile away at the Joint Operations Center. So if there is central control over disaster response, which there typically is, we can show all of these different pieces of data on that map in one place. Now, you could do that all over the world, really quick and easily. So we were really happy to get to test this. We don't often get to test this in a public sense. There was a medium Earth orbit backhaul set up, so we were doing all of this over extremely low bandwidth comms. Our integration specialist was able to downsample the video feeds specifically tailored to that low bandwidth using the Snowball to get the video back to the Joint Operations Center. The medium Earth orbit satellite was good, but it's not as good as what we all expect from our internet service providers with our cable modems and whatnot. So the last thing I want to talk to you a little bit about, and what's a talk at reInvent in 2019 without talking about machine learning. We were out there testing a new model. So one of the things Novetta does is we have a machine learning center of excellence, which is basically a lab to test new machine learning and AI ideas. And we were doing a new model that involves both computer vision and natural language processing. I'm sure everybody in this room has searched for images online. And when you do one of those searches, sometimes you get things that are relevant to the search term that you used. Well, what if we could automate that for first responders? And we had, say, a list of keywords that the cameras need to automatically look for in the field. What if we could retrain those models for different locations based on how people talk about things like danger, vehicles, people, to the locality that we're in? That's what this model does. And we were really excited to be able to pull the feeds from all the different cameras that we set up, whether it be a commodity-based camera, like the inexpensive IoT camera you see strapped there to the tripod, or a higher quality PTZ camera set up on the mast of that truck that I showed you. Being able to use the Snowball Edge to process all of that video locally with Greengrass is exactly what we were able to do in the field. So thank you so much. We're really excited about DR and what we can do with the Snowball Edge. I'm going to bring Ramesh back, and we'll leave some room for questions at the end.
Thanks, Matt.
Thank you.
Thanks, Matt. I was super excited to see his talk and his video and use case, and I hope you were as well. I'll spend a few minutes talking over and walking you through how you can use the Snow family of devices for data migration, special focus on large-scale, multi-petabyte data migration. So when you look at the typical customer challenges and the challenges you face when you're looking to move data to AWS, in places where you've got your data and you want to move your data from your site, you may not have consistent internet and network connectivity. That's one challenge that you face. Or you may have consistent network connectivity, but you may have bandwidth constraints, either because of production use for your regular use or just the amount of bandwidth required to move the data to AWS. And this table here kind of shows you if you had 10 terabytes of data or less that you wanted to move to AWS, even if you didn't have a very strong bandwidth network connectivity, maybe you could manage that data movement. But as you move to 100 terabytes, 1 petabyte, or more than a petabyte, think about 10 petabytes, it just becomes a bigger challenge even if you had a consistent, good bandwidth network connectivity to AWS. There could also be restrictions on the protocols based on if you had older mainframe type equipment or Unix-based systems where your data is residing today. You may have legacy equipment, legacy devices, older file share systems or older file systems that could make it a challenge to move data to AWS. Small file sizes could be a challenge because they just make transferring data over the network that much harder. And also depends upon where you're collecting the data. You could be collecting the data in remote and austere locations, such as a mine, in an oil field, or in a ship, or in truck fleets. So when you look at the AWS Snow family of devices for data migration, and this is something that I talked about earlier as well, but you can see that up to a petabyte or so of data, or at least up to 10 petabytes of data, you can make use of the Snowball and the Snowball Edge devices. They come in secure and rugged casings, of course. They're drop impact resistant, vibration resistant, dust and humidity resistant. You can leave a Snowball or a Snowball Edge device out in the rain if you want. Data's always automatically encrypted. Your data, the customer data that is stored on the device with 256-bit keys, the keys are something that you own and manage. The keys are never stored on the device, again, just improving the security of the transfer of your data on the Snowball and Snowball Edge devices. The Snowball devices come in two options, 42 terabytes of storage or 72 terabytes. And the Snowball Edge device, from a data migration perspective, supports 80 terabytes of data storage capacity. And even in a storage and a data migration environment, there may be cases and scenarios where you want to carry out some compute on the data before you transfer it to AWS. And of course, with the Snowball Edge devices, especially on the storage optimized as well as the compute optimized, you have the capability to run EC2 computing or computing with IoT Greengrass. The Snowmobile device, you can use that for up to an exabyte of data that you want to transfer to AWS. 45-foot-long container, secure and rugged, that can carry up to 100 petabytes of data. And again, it's got encryption. This also comes with security staff and GPS tracking as well. So just on the workflow and how do you use, how do you order, how do you place an order, how do you get one of these Snowball or Snowball Edge devices? Pretty straightforward. You place an order for a Snowball device or a Snowball Edge device on the AWS Management Console. You can also export data from your S3 bucket to your site or to your customer or partner site using one of these devices. During the job order placement, you can lay out any data that you want to be exported on the device. You can include any Amazon machine image that you'd like to include as well for any compute type capability. And we'll ship the device to you. You can select 1 or 2 day shipping. That's up to you. Once the device is delivered to you, you can copy your data onto the device, carry out any compute processing that you want to on the Snowball Edge device or on the Snowball device. And when you're ready, just ship it back to us, and we will import the data or import the results into your S3 buckets. As I mentioned, there are a few different options for the time frame you can use these devices. There are short-term options or one-time job options, which allow you to use the device for up to 10 days. And then we have the longer-term deployment options with 1 year and 3 year discounted pricing that you can use for longer term. And I'll take a quick minute to talk about some best practices that you can follow, especially for large-scale, multi-petabyte data migration. And some of the best practices listed here on this slide is something that we've learned working with customers like Netflix and Photobox in moving multiple petabytes of data from their various locations to AWS. There's a lot more resources available. At the bottom of the slide, you can see links to a white paper and a blog that's available on aws.amazon.com, where you can read through some of these best practices for large-scale data migration. And essentially, when you're looking at these large-scale data migrations, one thing to consider is to carry out a proof of concept or a POC ahead of actual migration of data to AWS. And you could do that with 1 or 2 Snowball devices that you can order for a test purpose ahead of the actual data migration. That just lets you discover the environment that you have at your site. It helps you plan for the data migration, helps set realistic timelines and workflow process that you'd like to get in place when you're ready to move the data to AWS. Again, making use of staging workstations, ensuring you have good network connectivity. This is internal network connectivity, so you can connect the Snowball Edge device or the Snowball device for the data transfer. Benchmarking the data throughput and copy onto the Snowball Edge devices and the Snowball devices. Again, that sets up realistic timelines for you. Messed up a little bit on the order of the slides here. So anyway, so give a quick example of a customer use case who moved 10 petabytes of data to AWS. And this is Photobox. And they're essentially an online personalization and personalized photo products company. They have millions of users around the world in at least 10 different markets. And what Photobox wanted to do was move away from maintaining and managing their own IT infrastructure and redeploy their resources for innovation towards with artificial intelligence and other aspects to drive better customer experience for their customers. They also wanted the greater and higher S3 data durability that they could achieve versus their co-location sites or even other cloud providers. So Photobox moved about 10 petabytes of content and data, about 5.7 billion photos, away from their EMC and IBM equipment to AWS. And in the process, they were able to realize cost reduction as well. Instead of spending 90,000 euros on equipment, they were now down to 13,000 euros in expenditure on equipment. And I want to talk about a couple of tools available from our partners. This one here is SBManager. This was recently announced and is available on the AWS Marketplace. Quantum Edge Services has a booth at the expo this week, so feel free to stop by and attend and meet them. And what they've developed is a GUI interface to manage and monitor your Snowball Edge devices and Snowball devices at your site. It's a pretty powerful tool. It gives you essentially all the capabilities that you can achieve on the command line interface on this graphical user interface tool, easy to use even for non-technical users. You can use it to monitor your devices, manage your EC2 instances, and with multiple devices, you have the ability to either configure and manage just one device at a time or a whole set of devices at a time. It keeps a good history of all your previous jobs and devices and configurations. So when you order new devices, you can quickly apply previous configurations to it. So pretty powerful tool, makes it easy, especially when you have a multiple devices and a cluster of devices that you're looking to manage. Another tool here is from Pixspan, Pixmover, and it kind of helps you with large-scale data migrations. Again, when you're looking at large-scale multi-petabyte data migration, you're looking at using multiple Snowball devices or Snowball Edge devices and having an easy GUI interface to manage those data copies at your site will go a long way in helping with those data migrations. If you like what you saw and heard today on the AWS Snow family, there's a few more chalk talks later today and tomorrow that dive into deeper aspects on various topics around data migration and edge computing with Snow devices. The first one here is by Matt, coming up in the next 45 minutes or so that he mentioned, so feel free to attend. And that's at ARIA, so feel free to attend that. And there's other sessions as well that provide a greater view on the Snow family of devices and other storage options from AWS. They'll be recorded, just similar to this session, and you can find that on YouTube. I'll take a pause at this moment and open it up for any questions that you have. After the session, I'll be around here or outside in the hallway, so you can feel free to talk to me at that time as well, or you can email any questions to me. Yes, we'll just wait for the microphone.
Good morning, Hein Funken from the Netherlands. Thank you for your talks. Does it work? Okay. Do you also, can you share a defense user story with the audience in this session?
Can you repeat that question again?
A Ministry of Defense use case using Snowball S3 capabilities on the edge.
Yeah, so some of the public use cases that I talked about was the NGA use case. That would be one that would apply. But again, I can only talk about some of those use cases where we've got permission from the end customer to talk about it. If there are no other questions, then again, as I mentioned, I'll be around. Feel free to talk to me or send me an email with any questions that you have. Thank you very much.